Hi, everyone. Good afternoon. As Brett introduced me, my name is Rotem Yossef. I'm part of the AWS Business Development Cloud Economics team. Yes, we have such a team. We specialize in the place where cloud meets traditional infrastructure from a financial point of view. So we meet our customers in two different, I would say, two separate occasions. One is before the transition to AWS, helping them understand the impact of moving to AWS from a financial point of view with, I would put an asterisk there, including the business impact. And then, which is much more relevant to you, when they're already deployed to AWS, or much more relevant to this specific presentation, we help them understand how to optimize their deployment. So we deliver tools, capabilities, and we help our account managers to conduct these conversations, and then with some specific customers, we do it ourselves, of course. So rule number one, I'm not going to read from the screen. I'm totally counting on your reading skills. So if anyone has a reading skill challenges, please let me know. Otherwise, I'm really not going to read from the screen, which moves me to this. Rule number two, there are no stupid questions. So if you have a question, even if you think that it's maybe, just ask it. I'll try to take your questions once you have them so it connects to what I'm talking about. If I see that it takes us too long, I'll just ask you to wait for the Q&A at the end of the presentation. But I will not be offended if somebody raises his hand or her hand and asks a question in the middle of me talking. And I'll do my best to take those questions when you ask them so they kind of connect. So let's talk a bit about the cost benefits of the cloud. Yay, some dramatic font selection. I can assure you this is the first and last time I'm going to be dramatic with my font selection. And actually, one out of the two times I'm going to read from the screen. Friends don't let friends build data centers. Why would we say that? Because it turns out that there are lots of costs. I mean, there are lots of benefits for the cloud. You can actually quantify the non-direct kind of cost, box for box, capability for capability, in all kind of creative ways, but this is not what we're talking about today. From a very straightforward financial point of view, there are a few pretty straightforward, give me a second here, advantages for the cloud, whether it is the idea of moving from, and it's not just the forecast, I'm referring to number one, not just the forecast in terms of I'm trying to forecast what to buy. It's think about the aspect of I'm trying to understand what I'm going to need 6 months or 1 year down the road, depend on your refresh cycle, versus I'm just going to use whatever I need. And my planning cycle is all about financially making sure I have the money to pay for it, or constraining myself from a financial point of view, but not from a resource point of view. So if something happened and it hits the fan, you can always like break this envelope and launch what you need to resolve the problem that you have, okay? Flexibility, your ability to continually change your design, change the hardware you use. You know, traditionally you order some hardware, it's all just in time nowadays. I don't know, like how many of you ever like tried to play with the idea of building your own infrastructure? Anyone? That's it, what? Yeah. Yeah, we just don't do it nowadays, right? Everybody here is around startups. You're not a legacy user. You're not like companies been around for a while. But if I look, and I know that this is less relevant for you, so you know I'm going to fly through this slide pretty fast. But for those who did it, in many cases, you order some hardware, you get it, it's irrelevant. When you made the order a few months ago, you had one thing in mind. By the time you launched, and you live in a crazy pace, right? Who here doesn't live in a crazy pace? Raise your hand. You shouldn't do that. If someone would have raised his hand or her hand, I would have sent them out. You don't belong here, okay? You live in a crazy phase. Things are changing, right? Your stack is changing. Your code is changing. Your architecture is changing. The idea of the problem you're trying to resolve is changing, sometimes on a daily basis until you figure out what you want to deliver. You don't want your hardware to constrain you. Economies of scale, that's a nice one because, again, you don't know this word, but I like to talk about it because whenever I say it, my customers start laughing. We cut our prices, and every time we do so, you pay less, same day. So whichever deployment you have on AWS today, I can assure you, for the same deployment exactly, you're going to pay less next year. Where exactly it's going to be less, how much less, I have no idea, frankly speaking. But you're going to pay less. Traditional infrastructure, you know, you could have purchased something, and you would have never had the experience of your salesperson coming to say that your manufacturers, that whoever sold you the service, coming back to you saying, oh, you won't believe it, we just reduced the prices. We have a check with your name on it waiting for you in our office. Just come and pick it up. Nah, doesn't happen. Okay? So your prices go down as you work with us. Managed services. Who here, who is not using an AWS managed service? Flavor of managed service. Good, I'm happy to see that. It's great. Saves you boatloads of time, money, but mostly focus. Your job, anyone's job here is to run infrastructure. Is that your business? So that's what your startup is basically around the business of managing infrastructure? So yeah, so one exception here, that's the business. But for most of you, your business is not to manage your infrastructure, right? Your business is to develop something cool that will do something awesome and basically conquer the market with your new idea. What you really want to do is have someone else run all this like infrastructure mess behind the scene for you. Build DBA, run your scale up, scale down, ideally use Lambda functions so you don't even have to look at servers. And you focus on writing the code that drives your idea and make it something huge and capable of handling as many hits as it will get because it's going to be awesome and you're going to have millions of users in like, what, a few months, right? Why not? So it works. And this one is really important, transparently attribute expenditure. It's important because you'll find out in many cases, and I'm going to talk about it when I define optimization, you'll find out that you're paying more than you thought. That's the huge gap between pay for what you use versus pay for what you need. Now, if you can tell what are you paying for, how much does this workload or process or whatever cost you, then you can define goals for savings. You can identify users in your system, employees, team members who are overusing specific resources. So this ability doesn't exist. Well, it exists in a very theoretical way out of the cloud. Typically just doesn't happen. It's trying to think if I ever seen 3 years, I've been with AWS for 3 years. I don't think I saw a single customer that could really allocate the cost of resources to a process, to a workload, to an environment or whatever in a traditional deployment. So let me introduce you to the Pareto Principle. Has anyone heard of the Pareto Principle? 2080? So basically, for whatever you're trying to do, most cases, 20% of the effort will deliver 80% of the gain. Okay? It's important because in many cases you don't need more than that. Getting to 100, which is typically impossible, or getting to 90-something, will cost you the additional ramp up from 20 to 80, 90, 100% of effort. It's really important for AWS because with AWS, we came to learn that EC2 and S3 and friends, the way I like to call them, S3, S3IA, Glacier, they're basically 70 to 90% of your bill. Now, I really hope that for you it's going to change. I'm going to see more Lambda and RDS and then Aurora, which is part of RDS, DynamoDB, those kind of managed services, conquering that part. But frankly speaking, for most of our customers, this is what we see. EC2, S3, and friends. Which is why we are typically focused on, when we talk about optimization and saving money, our major focus is on storage and compute. If you can really get that sorted out the right way, you can save a lot of money. And again, question, anyone here doesn't have money constraints? Anyone here raised billions of dollars and can do whatever they want? Raise your hands and then get out of this room. But, yes, so we all have, there you go. One person doesn't have money constraints. Thank you. So let's talk a bit about what you can do around EC2. First, Spot. I love Spot. Spot is the one thing that can be a huge game changer for you. There's a way to work with Spot, and it's going to be, I'm going to talk about it one of the next 20 slides down the road or something. But basically, if you can build your workload to work with Spot, and you do it the right way, this is most likely the cheapest way you can ever use AWS, even better than Lambda in most cases. EC2 Scheduler, that's a nice way to commence your experience of using resources only when you need them and not keeping them up. I'll talk about that later again. I mean, I'm going to talk about each one of those separately. And then EC2 Autoscaling, the same idea. Don't provision to peak, provision for whatever you need at any given moment. Scale up when you need, scale down when you don't need, and make sure that you are basically provisioning resources in a way that fits your workload and not just because at peak you need 10 C4 4XL, so I'm going to keep those up and running for 24/7. Reserve instances is, reserve instances, by the way, so you know, is a billing construct. It's not a physical construct, so it exists on the billing end of your relationship with AWS. It's a great way to save money, and the more you are aware of the way you are committed to AWS, can commit to AWS, the more money you can save. A great way to save money with reserve instances is the new, relatively new convertible instances. I'm going to talk about those later, so I won't be talking about it right now. Now, if you really want to take it one notch up and do it the right way, use CloudWatch metrics plus Lambda to automate. Now, don't forget to tag. You can't really automate the right way if you don't tag the right way. Gorilla Stack is the right way to do mass tagging and automated tagging. And I think you're going to have access to all of those, right? We're going to share the slides with you, so there's no need to snap. If you want to snap, I don't care. But if you want to listen and get the slides afterwards, you're going to have access to all of those slides, okay? So using Lambda plus CloudWatch can automate. Give you an example for Lambda plus CloudWatch. You can say any instance after 8 p.m., every live instance that is not tagged as production goes down, unless tagged as keep alive. If keep alive, look for tag until when, okay? Or it might be just keep alive. It depends on the complexity that you want to create. But a smart way to use it is to build a system, build your infrastructure in a way, your AWS infrastructure in a way that your team can say, okay, I want to keep that instance up and running until that hour. I don't want to kill that instance at 7 p.m. So I'm going to like press the button for keep this environment, keep this instance up and running, drop-down list until when, enter, and it will auto-generate the tags for all the relevant instances and might be EBS volume or whatever. And the automation, Lambda automation would like check every hour, for every round hour do, check instances, kill whatever has to be killed, okay? That's one example. A very interesting one, by the way, is, I think it's just relevant for you, but I really like this example, is for recovery. You know, sometimes you have a DR situation. And when there's a DR situation, sometimes there are multiple customers have DR situation. And you might be challenged spinning up instances at that point that will fit exactly what you need. But what if you have a deployment over, let's say, 50 instances, 100 instances, and you tag the instances with a tag that says this is DRable. That's an instance I can kill in order to deliver to address a DR situation. And then whenever there's a crash, whenever something happens in the system, you automatically reset all of those instances that are tagged as DRable and throw in the appropriate AMIs for the critical workloads and start working with those. So let's say you had 5 such instances and you need 10 now, you have 5 less to worry about. So tagging can be really powerful in all kinds of situations. I gave you this example just to demonstrate how tagging can be powerful in resolving those all kind of challenges. It's not necessarily just that, okay, I want to kill that instance, I want to spin it up, spin it down, whatever. Cost awareness and education. This is really important. Like, especially, again, startups. You have small teams, right? Anyone has like a team of more than 5 developers here? Raise your hands. Keep them up. More than 10 developers? More than 15? More than 20? That's it. Yeah, so most of you don't even have 5 developers. So it's much easier to just educate at this point, make sure that your developers are focused on building your product and have the right education, and start building tagging strategies and automation and so on and so forth. You have to find a tipping point. Where does it worth investing in automating everything that we do? And where should we just educate? So speaking with your data resources, making them aware, using a simpler kind of tagging schema just to understand who's owning what so you can debrief and understand, oh, my cost just bounced up by 50% a month. The number of customers that I had did not bounce up 50%. What happened? Who owned those specific components that are now costing me more, and so on and so forth. A very efficient way to identify those kind of challenges to say, okay, something is going wrong here, is looking at idle resources. So if your team is aware of that and you educate them and they're aware of idling is not good, and that all they have to do is just look at the dashboard. Look at CloudWatch. Okay, you can either use CloudWatch, you can, some of you should have access to Trust Advisor, give you some inputs about that, or you can actually build your own dashboard. And you look at that, wait a minute, something is idling here. So without any automation, well-educated team can actually save you a lot of money just by looking at the right things in the right time. Okay? Cool one, use CostBot. Hey, Rotem, yesterday your service was 28.33, which is 8% more than the week prior. Hey, wait a minute. Why am I paying 8% more? Maybe I just added a service. Maybe we just added like a new functionality that wasn't there before. Okay, that makes sense. Maybe we just bumped up our service and we have 20% more customers. Also great. But what if nothing changed? So did someone leave some machines on? Are we doing something wrong? Are we underutilizing one of our machines? Somebody just installed, span up too big of a machine. Okay? So it's kind of giving you an indication. Then you can take a quick deep dive into it, send an email or a Slack message to your team. What's going on? Figure it out. Resolve it. A very useful and straightforward parameter or metric to use is cost per user. It's pretty simple, basically. You look at the number of users, look at your cost, calculate the cost per user. You should expect that to go down as you become bigger, because there are all kind of underlying infrastructure and workloads that you are using to, for example, for build. Those are kind of typically static. They're not changing unless you're increasing the size of your team. And the more users you have, the overhead is lesser per user. So if you see that it doesn't go down for you, if you see that the cost per user goes up significantly, then again, I might be doing something wrong. Worth taking a look at that and debriefing and understanding what's wrong. You can build your own dashboard. It's pretty simple, actually. This one specifically was built with Tableau. That's it, I forgot the name. Shoot, yeah. That's it depends. You should like define it's cost per user per time frame, right? You can do cost per user per day. I wouldn't do that, but maybe it can be per week, per month. Like get an indication of like whichever cut you want. Generally speaking, our billing would be per month, right? So you look at the billing, monthly billing, cost per user per month, be a great way. If you want to do it per day or per week, then it takes much more rigor in terms of like breaking down the costs per day. It's doable. I would say that it's not something I would recommend, especially not for startups that you're looking for the quick ways, right? You're looking for the fast, quick, and dirty ways to get an indication that something is wrong or something is good. You don't want to take a deep dive into a platform like Cloud Health, install Cloud Health, pay them 4% of whatever you're paying AWS, and start understanding how it works. Or writing your own scripts or your own, or build your own super complex dashboards that do that. At this point, you want a quick and dirty. And monthly number, that's a very easy quick and dirty way to calculate that. Okay? So going back to the dashboard. This one was built with Tableau, pretty simple. Use some metrics, savings, spend, so on and so forth. Oops. This one took about, I think, a day to build. And for some of you, this might be a great solution. If you don't feel comfortable with what you get from CloudWatch, you want something much more specific, you can build that. You can put it on a screen, put it on a screen somewhere that everybody can see it. And then when something bumps up, you can say, hey, wait a minute, something is wrong. Right sizing. Right sizing is pretty simple. It's basically saying, I'm going to use what I need versus what I kind of felt like spinning up. Or it goes to the definition of optimization. You want to pay for what you need, not for what you use. You know, for AWS, you pay for what you use, but you can actually use, I'll give you an example for my own flesh and blood, okay? I'm working on a project internally. Everyone is like, the whole thing is voluntary. I can't explain what it is because it might become a product eventually, like almost everything with Amazon, which is actually cool. We transitioned from a server underneath the desk to AWS. Yes, we used to have a server underneath someone's desk, and eventually we're like, okay, well, I think we should do something better than that. Guess what? We wish we had this option to spin up servers. Oh, wait, we have AWS. Let's do that. So we got some budget, and we launched AWS. I look at my deployment. I have 3 C44XL servers. Now, I know exactly how, I know my code base. I know what I need. And I'm not writing code. I'm not a programmer, but I got to be a in computer science. I'm like providing those things all the time for customers. So I know what to look for. And it just doesn't look good. So I reach out to my developers and like, OK, guys, let's take a look at our dashboard. We look at the dashboard. Anyone wants to try and guess what was our utilization? Throw a number. Anyone? 0. No, not that low. Not that bad. Yeah. 5. Who said 5? 6. We're at 6% utilization. So I asked my dev, like, dude, why are we at 6% utilization? You won't believe how good it runs. It's like, yes, because you oversize yourself like 4 times, or sorry, it's 8 times bigger, 4 notches up, 8 times big, 3 notches. Right, we're saving, about 8 times, yeah, 8 times too big. No, you don't understand. It runs amazingly. See how fast we're serving like requests. It's like, yes, you would serve it just as fast had you used like half the size or quarter the size, actually 8 the size of the server. And I was like, okay, would you mind switching to a C4 large? It's like, okay, switch to C4 large. Guess what? Is our latency looking bad now? No, we have the same latency. We're at about 50% utilization at this point, something like that. We're working on our code. Our code wasn't ideally written as an understatement. And we're going to transition to a T2 medium. Huge saving, just because we looked at the size of the server and was like, oh, wait a minute, this instance is way too big. Doesn't make any sense. Look at utilization. You know, anyone here is a dev? Okay, close your ears. Okay, so who's doing the business here? Who's owning like finance, business? Nobody? So what kind of roles do we have here? Like anyone who's like a founder. And who's a founder? Founder, not dev. What else do you do? Give me throw some words. Dev. So you're all dev. I can't tell you dev jokes. I'll tell you anyway. So anyone here has kids? I know it's not the audience, but anyone has children here? Oh, okay, thank you. Thanks, guys. I appreciate you being here. So I can tell you the kids joke. So what would happen had you taken your kid, left him or her alone in a candy store? Tell them, I'll be back in 30 minutes. Take whatever you want. You come back in 30 minutes. What do you see? Your child is most likely throwing up sugar at this point. They have this kind of weird goo in their pocket that used to be sweets. Yes, they are still reaching out for more, right? Correct me if I'm wrong, parents. That's exactly how it's going to be. And that's your dev resources when you give them free access to AWS, one-to-one. Okay? Because it's cool, because it's fun, because I can spin up bazillion workloads and bazillion instances, and I can test whatever I want, however I want, and I forget it on. Who cares? I'm not paying for it. I'm a dev. Guess what? Somebody is paying for it. So right sizing is all about fitting it exactly to what you need. Get it to the right size. Now, right sizing doesn't mean that if you're using a C4 for Excel, you're going down to C4 large, because you might be utilizing 20% of your memory, but 40% of your CPU. So you need a less memory-intensive kind of instance. Now, you're a C with the least one, but let's say you were using an M. And you would have 20% utilization of memory, 40% utilization of CPU. then you can go to a C, which has half of the memory. Why paying for memory you don't need? So right sizing is about moving up and down the stack and moving sideways to the right family to the point where you're hitting your sweet spot for utilization. 80/80 is a good place to be at for most workloads, 80% utilization. If you go beyond that, you can always go up the stack, one notch up. You use the C4XL, go to C42XL. Don't go to the C44XL. When you hit over 80%, again, switch to the next one if you have to go vertically. Ideally, you're not scaling vertically, you're scaling horizontally, right? So you're going to use the smallest instance you can, and you're going to add another one of this when you need it, and then another one, and so on and so forth, which is the best way to go for most. And again, you guys are writing code from scratch. Ask you the question, since everyone is dev here. Who is scaling horizontally? Who wrote their code to scale horizontally? That's it? Raise your hands. Hi, hi. Horizontal scaling. Raise your hands. Hands in the air. Okay, vertical scaling. So the others are not writing code? They're not scaling at all? You have no plans to grow? You like the idea of being a cool startup, sitting here at the loft, hearing lectures, and then one day taking becoming an industry hire or something. No plans to grow, okay. So we have multiple families, and the important thing is to select the right family, and then select the right size. It's, I'm not, frankly speaking, as I said, remember the slide about the 90%? 90% EC2 and S3. So all of my optimization efforts with customers, like 90% over the 90% is over the EC2 and S3. So I'm not that familiar with the way you optimize for RDS. I would guess that there are instances that are better fit for RDS, and I would guess, a wise guess would be that these are the recommended instances. But we have solution architects here, and that would be the great resource to ask that question. I don't want to give you a wrong answer there. Shoot. So vertical scaling is when you say, like, I got a C4 large. I need more juice. I'm going to switch to a C42XL. From my C42XL, and then transition to the C42XL. First problem you most likely already figure out, you're going to hit a wall, a ceiling at a certain point. There's only so much you can grow that way. Second, you have to do the context switch between one to the other. It's getting complicated. Now, if you're working horizontally, you need more juice. You need more capacity. You just launch another one of the same one. And then another one, another one. You don't need them, you kill them. Okay? So it's just like Hadoop cluster. You have a manager, you have boatloads of slaves, and you just like ramp them up when you need, kill them when you don't need them. It's much, much easier to grow horizontally than vertically. Where do you see vertical growth? Typically, legacy solutions that were not built to grow horizontally for all kinds of reasons. I don't think that anyone sitting in this room should design code to grow vertically. 99% of the cases for new code.
So horizontal scaling will be only you have scenario where you don't need those many resources for the whole thing, right? You can
scaling. So the question was horizontal scaling would be when you don't need that many resources for growing. Scaling means that you're out of resources and you need more. There are two ways to do it. I have this size of box. I'm going to double it and use this size of box. The other way is like, I have this size of box, I'm going to add another one of the same size. Okay? Lots of advantages to this one, to adding another one of the same size. Another one is that when I need the third one, I add a third one. On the other one, I went from 1 to 2, the next one will be 4. So now I have 25% of underutilized infrastructure, right? Make sense? So you want to design, and it gives you so many other advantages, like we talked about Spot, it's going to be that as well. Damn, we're already 30 minutes in. Okay. So that's what I spoke about right now, like horizontal scaling. That's exactly what I spoke about. So horizontal scaling is, the messaging here, the other things we've said here is basically, when you need more, you don't necessarily need to launch another instance. Sometimes all you need is a bit more CPU. So if I need more CPU, and I'm using, again, let's say I'm using an M, I can switch to a C. And in this case, I will still keep the same memory, but it will double the CPU that I'm using, right? I need a bit more memory. I'm using an M. I can switch to the R, okay? Double the memory, keep the same CPU. So that's one. But then when I need to grow on, like, double capacity on both ends, that's when I want to grow horizontally. So now I know that R's are the right instances for me. But when I need two of those, instead of saying I'm using an RXL, let's switch to an R2XL, I would just launch another RXL. Okay? EC2 right sizing, pretty much self-explanatory. It's a script that basically evaluates your workloads for you and give you an indication about the right size of the workload. It looks at the CloudWatch metrics, so generally, I mean, the idea is that you can do it on your own if you only have a few instances, but when you're talking about scale, you have hundreds of instances, or even tens, that might get a job done for you. Trusted Advisor is, the full set of features is actually available only for those who have enterprise support. I wouldn't say that most of you should have enterprise support at this point. I would actually advise you not to. It just costs too much for your size at this point. But when you hit it, it's actually pretty cool because we'll give you all kind of indications and tell you all kind of interesting stuff. Another option which I'm not talking about here is partners. Again, this is when you grow a bit bigger. Cloud Health, Cloudomize, those guys can help you manage your infrastructure. They would take a certain % of your AWS bill, so typically 4%, I believe, is what they charge, and they give you all kind of insights about your infrastructure. Load testing. Load testing is a great way to save money because in many cases, you would allocate resources assuming you're going to need a certain load. And you say, yeah, I'm going to hit this kind of load, which is why I'm going to allocate this kind of resource. Well, that's basically doing kind of a WAG estimation, right? Well, it's very simple to do load testing. You got boatloads of tools that allow you to do that. So just do load testing, understand what you really need for the load you're expecting to have, and deploy the right size again, rather than just wagging it and finding yourself paying too much for something you didn't need. Reserve instances save you up to 75%. Now, I would caveat it and say what you would typically see would be up to 65%. What you would specifically see, I would say, is around 35% because you would typically not commit for 3-year RIs. Okay? If you are willing to commit for 3 years, I would go with the convertible RIs. I'll talk about it in a second. So I would say for 3-year RIs commitment, about 65%. The 75% is for very, very specific storage optimized instances, the I's and the D's. And then you would see the scale about 61 to 65 for the more common instances used. When we talk about RIs, cover all of those guys. So it's not just pure RIs, it's any service that is EC2. So not just pure EC2, sorry. Not every, like just I'm spinning up an instance. Any service that is instance-based can be RI'd. Bringing me to convertible instances, which is actually convertible RIs, which is something that can be very useful for you. So if you're at a point where you say, like, I have some money in my pocket that I can use, not that rich, but I have some money, but I want the flexibility, convertible RIs let you change all of those. Family, size, operating system, tenancy. Actually, the one thing they don't let you change is switch between AZs. Sorry, switch between regions, not AZs. AZ, like regional RIs are already baked into that. So switch between regions. So as long as you know that you're going to stay within the same region, these guys will save you about 40 to 45%. They will require you to commit for 3 years, but on the other hand, you can change that as many times as you want. The only time you can change is if you already issued a request for a change. We didn't provision it yet. You can't change the change. You'll have to wait for the new provisioning. When that happens, you can ask again. So let's say it takes us 48 hours to provision, you still can do it about 180 times a year. Anyone needs more than 180 times options to change your workloads, change your commitment, your RIs a year? I don't think so. I haven't seen a single customer that needed more than that. So these are great to save money. It requires you to put some investment up front, paying for a 3-year RI, but they will give you a very nice discount that pays off significantly after that. Quick comparison. As I said before, 1 year ROI is about 40, 3 years about 60, convertible about 45%, but convertible gives you the flexibility of switching the infrastructure as many times as you want in a very convenient way. Storage. It's pretty simple. Amazon S3 is our hot storage. Anyone not familiar with S3? Oh, sorry, go ahead, before I go back. So the question was, ask it. Asquith asked whether a reserve instance is an upfront cost. Yes and no. You have 3 ways to reserve instances. One is no upfront. The other one is partial upfront. The last one is all upfront. The no upfront means you are not paying anything in advance. You're paying on a monthly basis, but then the discount is significantly lower. Partially upfront is the way to go if you ask me for most cases. You would pay some of the cost in advance, and then you have a monthly pay as well. So it adds up to a significant saving of, let's say, roughly 60%. The all upfront give you about 1 to 2% more of saving for paying all upfront. So if your cost of capital is a good fit for that, then, but you're not there in most cases. It doesn't make any sense for startups. I would typically go with partial upfront if you can allow yourself to do it. Otherwise, no upfront. So the question was, what do we lose in terms of discount if you go no upfront? I think it was like 35%, something like that, to 60, something like that. Don't catch me on the numbers. 40 to 60, 35. It really depends on the instance, but it's pretty significant. So it's like 20% gap or something like that between the partial upfront to no upfront, but then only 1 to 2% gap between partial upfront to all upfront. So I typically recommend going with partial upfront. Storage. Anyone not familiar with S3, SPIA, or Glacier? Raise your hands if you're not familiar with it, because I really I think of skipping on that because we have only 23 more minutes and a few more, much more interesting things to speak about. Anyone not familiar with S3, S3IA, infrequent access, or Glacier? Anyone not familiar? Okay, so I'll do it quickly. S3 is our hot storage. That's the most durable, reliable, redundant, and so on and so forth storage that we have. Then we introduced Glacier. Glacier is our cold storage. It's actually much better today than what it used to be. Can't go into the details now, take too much time. But this is the one that costs you like almost nothing. And basically, you pay for it by having to pay whenever you retrieve data and for having to wait when you retrieve data. Great for archiving. And it's also redundant and has great durability and so on and so forth. Then we introduced SPIA. SPIA is a very interesting kind of in-between solution. Okay? It's not too cold, not too warm. The idea of SPIA is that most of your data, think about your laptop. It's a great analogy. How many files or what % of the storage in your laptop do you access on a monthly basis? I can tell you that about 90% of my files are just sitting there collecting dust. With SPIA, you pay about 50% less than what you pay for S3. Used to be more than that, but now it's only 50% because we discounted S3. And you have to pay for retrieving the data. There's like minor differences between them. You can see it over here. Just typically it's here. The availability, 1.9 difference. But you pay significantly less. That's a good point. That's a good slide. For SPIA, and then you pay for the retrieval. So if you're not accessing this file, so for example, if you're accessing it only 10% a month, then you're saving 41%. Because you pay another cent per gig month for accessing it. If you do 0% per month, it's closer to 50%. So the break-even point is accessing 100% of the data once a month. Now, if you know which piece of your storage is being seldom accessed yet, when you need it, and you throw it into SPIA, you're going to save a lot of money. That's the one trick that saves you boatloads of money, because most of your files most likely are accessed very rarely. You have the files you're working on a daily basis. A good measure would be many organizations do like transition to SPIA after like every file that wasn't touched for 60 days or 90 days, SPIA. Some will do 30. Okay? Good.
How does that help to offload? Doesn't it take some of the files off to the local to edge?
Question was, what about CloudFront? Catch me after the presentation. I just don't have time to go into it now. Okay? It's not part, again, it's not part of the 2080. It saves money in certain cases. If you need specific capabilities, it will definitely save you money. That's why it's there. Latency as well and stuff, but it's not something that I'm covering right now. What? It depends. Let's talk about it after presentation. So break even is about 100% retrieval per month. Managed services. It's very expensive to hire good resources. And what you typically see that you start comparing the cost of managed service versus doing it on your own is that as you grow, you need more and more resources while the managed service stay more or less stable. The reason is that with managed services, let's take S3 for example. How much storage, how much S3 storage can one individual manage? Anyone want to guess? How much volume of S3 storage can one individual manage? Storage admin. Generally speaking, unlimited. You don't have to do anything. It's like managing your own storage on site. Right? What do? Allocate. Provide permissions to people, which can be automated. You don't do too much. Okay? Versus on-prem. So much work around storage. Generates so much noise and people are focusing on it. So, which is why I highly recommend utilizing, that's just one example, but it's true for anything as DBAs. You know, every time I've heard DBAs telling me stuff like, you know, I would really like to get out of the DBA business. Be more creative. Support my team in a way that helps them deliver value, not just sharding, cleaning, asking questions, annoying questions to get things sorted out because our database is underperforming and so on and so forth. Density. So when we talk about density, containers are a great way to increase the density on each one of your instances. And basically you take, like, say, 5 EC2 instances, instead of using it that way, kind of do something that is more of like that. And then you can use, instead of 5 separate EC2 instances, each one with a different utilization, some of them pretty low utilization, you can actually get all that together with EC2 container service layer and use only 3 EC2 instances, which is representing 40% savings. Now, again, like everything in life, just like Lambda, containers is a good fit for certain workloads, not a good fit for other workloads. It's your job and your dev team to decide whether you want to containerize it or not and use the right way to do it. I'm going to talk about Lambda in a few minutes. EC2 container service is highly scalable, high-performance container management service that is a perfect fit for the AWS ecosystem. You must have heard that we're also doing Kubernetes. So we're basically allowing you to use whichever framework you want with AWS. And if you want to do containers, that's a great way to increase your density and save money. So just take a quick look at development workloads. Remember I told you that idle is a sign for waste? So look at this graph. Picking up a bit, whoop, going down. What's going on here? So see that somebody had some work to do, some dev work, whatever, dev, test, run some code, and then the instance is staying there doing nothing. And this is indicative of a waste. It means that you could have shut off, you could have like kept it off for quite a while, and then shut it off right after the user who used it completed the work, right? So if you look at that, some people would actually provision 15 instances all the way through. But the right way to do it is actually provision it over here and start cutting them off as you need less, or scaling down, scaling up per need. One way to do it is to use the EC2 Scheduler. You know that your dev team is showing up to work at 8 a.m. in the morning. No, they don't. They do it at 10 a.m. most likely, right? So you know they show up at 10 a.m. in the morning. You know they'll typically stay there until 8 p.m. in the evening, 10 p.m., whatever. It really depends on which stage you're at as a startup. Sometimes we just stay there continually until 10 a.m. the following morning. And if you know that something has a pattern, you can schedule it. Now, I remind you, spoke about it beforehand. If you really want to go advanced, use Lambda and CloudWatch and automate it. But this is a great way to start. Just use a simple scheduler. I'm ramping up some environments, and then I'm ramping them down when I don't need it. So about that. Autoscaling. 2 ways to autoscale. One is to scale a schedule. I know that every Thursday, my user base, or every Friday, the end of the working day, my user base is accessing my application. So I'm going to ramp up my deployment on Thursday, 4 p.m., sorry, Friday, 4 p.m., and ramp it down whenever I know that there's less usage. I personally am less of a fan of that. It can work for very specific workloads and requirements and needs. I'm much more of a fan of this. Scaling by policy, identifying, setting up a threshold. If threshold hit, then we typically say scale up fast, scale down slow, because you never know what's going to hit you. Scale up by multiplying by 2. Scale down by -1. And define the right rules, it will basically jump up and then slowly go down while encapsulating all the bumpiness of the customer behavior. Okay? You can use the ChatOps to power on instances, like, okay, Mr. Bot, start dev. It will just power up the instances. So basically saying, I'm not going to automate it. I'm not going to use the scheduler. I'm going to let my team spin up their workloads when they need them. Now, even if you do that, I would still go back to shutting them off automatically, because a dev cannot work without the workload, so we'll definitely have to spin it up, right? But they can go home without shutting it off, and then you're still paying for it. Shoot.
So you say you support Kubernetes, right?
Support what?
You support Kubernetes.
Yes.
So does AWS Scheduler interact?
No, I think again, I'm not, as I said, most of my work is not around container stuff. I know that we announced that we will be supporting Kubernetes. I believe you can implement, to the best of my knowledge, you can implement Kubernetes, but not with native support.
I use it for the
Yeah.
question is, if I can integrate the scheduler with Pops, that would help me to manage my cluster, which is effectively taking down the workload of AWS.
I believe, again, this is not something I specialize in, and I don't want to give you the wrong answer. I believe the scheduler is in a different layer. If you come back, Kubernetes sits on top of the EC2. Okay. So it's a bit like you will have. I believe you will have to customize it. Correct me if I'm wrong. This is not compatible. T2s. You won't believe how much work can be done with T2s. These are the cheapest instances we have. Okay. You can't go cheaper than a T2 instance. And one of the things that we saw customers doing is actually saying, hey, you dev, if you want to spin up a T2, go for it. Anything else, you have to talk with me. And then suddenly, like, a whole operation that used to spin up M's and C's and R's, switch to T2 and it works. So try to use T2s when you can. They are much cheaper than anything else that we have. An example of optimization on a pipeline. So, well, you build your pipeline and you see that something here is a bit overloaded, right? See, like 1 minute, 18 seconds, everything else like a second scale. That's 1 minute. It's maxed out. So one option is to use the Jenkins plugin for Spot and deploy more Spot instances to support a specific workload. Now, why am I using Spot? I'm talking about Spot because I love Spot. Who doesn't know Spot here? No Spot, same there. This is really important. I'll tell you why. It's important because what have I done? Okay. Okay. Crisis averted. Because if you do it right, you're going to save up to 90% of your on-demand cost. Now, before I even talk about how to use Spot the right way, when I say 90% savings, there is no line in the code that says if more than 90, then 90. It does not exist. So if you are smart enough and you can save 92%, you'll save 92%. I'll give you a tip. There are companies that leave off Spot. They specialize in Spot. The workloads are like tailored to Spot like this, laser focused. They report they save 92 to 94% versus on demand. It's not easy. It's a skill you have to develop. It's code you have to write. It would have been so easy, everybody would have done it. But if you know how to do it and do it right, then it's worth it. I would say that a good measure for Spot, using it right without being super specialized, would be 80%. Had I had the time and the board, I would have shown you how I get to that number. Very intuitive process. But before that, let's talk about Spot. What need happen for you to work with Spot? So default tolerant and stateless, these two are mandatory. It's not an option. Okay, sorry. Anyone doesn't know how Spot works as a marketplace? Doesn't know? Okay. Spot is a marketplace. You bid. It's our excess capacity. We have capacity sitting on the shelf which nobody is using. And what happens is that we say, okay, whoever is willing to pay the highest price, all yours. Okay? So you bid for it. You say, like, this is $5 an hour, I'm going to bid $1. The moment, let's say you have 5 people who bid, one bid 1, 1.5, 2, 2.5, 3. Okay? 5 bids. And let's say we only have 3 instances available. Then there. 2.5 will get it, 2 will get it, $3 will get 2.5, and 2 will get, those bids will get the instance. They will all pay $2 per hour. They all pay the lowest bid. You don't pay what you bid, you pay the lowest one. But the guys who bid 1.5 and 1, they will not get those instances. So it's a marketplace. So the catch is that after you got it, I might take it away from you. I will give you 120 seconds, and I'm not even telling you that is going to happen. You will have to actually ask the instance. Recommendation is every 5 seconds. And you will have to ask the instance every 5 seconds, hey, are you due to be terminated? It doesn't tell you, oh, actually I am. And then you know you have another best case scenario, like 119, worst case scenario, 115 seconds until this instance is being taken away from you. Once an instance is due for termination, there's no way to roll that back. You can't say, oh, you know what, I'm going to bid higher. No, not an option. Should have thought about that before. Okay? That's the catch with Spot. And because of that, you must be fault tolerant and you must be stateless. It doesn't matter how sophisticated you will be with your bidding strategy. I can assure, there's only one thing I can assure you about Spot instances. I will take them away from you. Even if you bid 10 times, you can't, but even if you bid 10 times more than on demand, I can assure you I will take this Spot instance away from you. It's just a matter of time. It might take less time than otherwise. But I will take it away from you. So if you are not stateless, that's going to be very painful. If you're not fault tolerant, you're going to lose some data. It might be very painful. So be stateless, be fault tolerant. Loosely coupledness. Generally, we say be loosely coupled. I say be as loosely coupled as you can. Don't go wild. If you have 10 instances working together, chained to each other, and once one is down, you have to reset all 9, that's a bad idea. If you have couples, most companies, most teams can work with it, can live with that. So be as loosely coupled as you can. Evaluate it per your own workload and the way you want to work with Spot. There are all kinds of ways, all kinds of creative ways to work with Spot. Some will demand you to be loosely coupled. The most important thing, once you satisfy those 3, is to be flexible. Be flexible with the AZs. Be flexible with the region. Be flexible with the sizes. Be flexible with whatever you can. I'll give you a quick example, super quick example. I'm going to do it very fast because we're running out of time and I have so many other things to tell you. If you take an instance, let's say a C4XL, and let's say the C4XL on-demand price is $10. Let's make it easy. And let's also say you can get it Spot 90% discount, which means that you will pay how much? $1, right? But let's say you cannot get it. But there's a C4 2XL available for you, twice as big, which is supposed to cost you $20 a minute, an hour. How much will you get it for with 90% discount? $2, exactly. So let's take these $2 you have to pay for the twice as big instance and compare it to the on-demand price of the instance you started with, the C4XL. It's still 80% discount, right? So you started from something that you would have paid for on-demand $10. You can get twice as big for 80% discount. Would you take it, yes or no? There you go. That's a very simple, straightforward example of flexibility. Now, you can go, you can just take an instance that have more memory, same CPUs, more CPUs, same memory, doesn't matter. In all of those cases, you will have enough of resources, and you still save about 80% if those are available and not what you exactly needed. So that's what I'm talking about flexibility. Again, I can spend about like 20, 30 minutes just talking about the right way to do flexibility, but unfortunately, we don't have the time for that. Remember that And trust me on that. There is always spot capacity available. If you do it right, if you're flexible, there will always be spot capacity available for you. So if you don't see the spot capacity, you are doing something wrong. And you have to trust me on that because we don't release those numbers. There's no way for you to know it. But I'm telling you again, remember that. If you are deciding to use Spot, you are deciding to focus on leveraging Spot for your startup, and you don't see Spot capacity available, then you are doing something wrong. Look for the Spot capacity in various sizes, types, AZs, regions. You can find it and save boatloads of money. Going back to our CICD and the build process. So actually, there's a much easier way to do it than doing it that way and finding out that you have some maxed out resources, which is using a managed service that does it all for you. And that's the AWS code build. Worth taking a look. We have like a whole array of services that basically help you build and deploy your code pretty easily, and again, let you focus on writing the code and building it and designing it to do the magic that you want it to do. Great thing to leverage. I think this is the last one. One of my favorites, which is serverless architecture. Serverless architecture, Lambda. Everybody heard of Lambda, right? Who doesn't know Lambda? Raise your hand. Hand of shame. Okay. First homework after you get out of this session. Learn about Lambda. It's a very powerful tool. It does the, got 4 more minutes, right? 4 more minutes? Okay, great. Lambda basically allows you to write the functions, throw the functions into Lambda, and we will do all of the provisioning for you. Whether your function is being hit once an hour or 10,000 times a second, AWS will provision the resources to make sure this function works for you. It has to be event-based, and I would say that another good number to look at when you say, like, wait a minute, it's going to cost me less? Yes, as long as your server is utilized about like at 50% of the time, more or less. Now, it depends. I've heard various numbers. I think 50% is a good one. If you have a server that works hard, more than 50% of the time, which is untrue for over 90% of the workloads I've ever seen in my life and the customer I spoke with, then you'd rather spin up a server in one form or the other. If it's lower than that, Lambda is a great solution. And it takes away your need to scale up, design, think about it, just write the functions, get to work. You have companies that build their whole business on serverless architecture, where they're using Lambda functions. This is what I said now, yeah. No servers to manage, continuous scaling, and I forgot to mention subsecond metering, so you're actually paying for the fractions of seconds that you are utilizing the resources with Lambda. So, quick example of serverless. An API call from the API gateway, hit the Lambda, Lambda launches the function run whatever operation you want to do on DynamoDB and shoot it back. No server in the loop. No EC2 here. You don't see any EC2 here. So, let's summarize it. When you're using the cloud, it can help you focus on the right things. If you do it the right way, if you optimize it, it helps you focus on the right things. It helps you save you a lot of money by only paying for what you need. Okay? Don't pay for what you use, pay for what you need. Make sure that what you use is what you need. And then you can leverage containers and serverless to like go one notch higher in basically letting managed services manage your infrastructure for you and save even more money and save even more time. Now, if you ask me personally, and I'm focused on the finances more than generally speaking anything else, I think that your time and your managerial and mental focus is much more valuable than the time the money that you save. So you might be saving 20, 30, 40% using serverless or containers, managed services. But the fact that it frees your most important and most expensive resource, which is your time and your focus on the business, that's worth much more than that. So if there's one thing I want to take from this presentation, it's actually not the fact that you're going to save money. It's the fact that you're going to make your business more successful. You're going to make your startup more successful by focusing on writing the code that does your magic. And you know what? Even if you fail, you're going to fail faster and spend less time of your life on this iteration of your creativity before you move to the next thing that you do. So we have some additional resources. Basically, it's here so when you get the presentation, you can use it, so I'm not going to review them. And this is supposed to be questions. I don't know why it doesn't show the word questions, but. Okay. What is the maximum time for reserving instances? There is no limit. As long as I don't need it, when I say AWS don't need it, you can keep it. So if you find a sweet spot of a spot pool, sorry, I can't define spot pool right now, but if you find the right spot pool that nobody is using, hidden somewhere in the depth of a region that everybody forgot about or I don't know what, yes, you can spin up an instance and keep it for years. Nobody will touch it.
So let's say if I'm running a job, which is taking, let's say 15 minutes, and I reserve the spot instance for that. And so
You don't reserve. You spin up a spot. It's not a reservation.
yeah, and if I get that instance, so it doesn't give me guarantee that for 15 minutes.
We have spot blocks for that. It's a different product for Spot, which you are, in spot blocks, you are saying, I need 50 instances of this for 4 hours. If you give it the thumb up, we might give you a thumb up of a partial subset of that, then you have them for 4 hours. We are committing 4 hours, but then the discount is much lesser. If you want to touch that 90% discount, then one spot blocks was built because of this kind of workloads, like rendering in a file. You render a video, spot blocks. So companies who would render video files would need to render those files for 3-4 hours, and if it's not completed, they lose all the value. So they paid for Spot for like 4 hours. We took it away from them immediately before they completed the rendering. File is useless. That's why we are offering Spot blocks. In general, just so you know, if we take the Spot away from a Spot instance, you don't pay for the last hour, for less than 1 hour. So let's say you launch an instance, and you've been using it for 59 minutes, and then I took it away from you, you don't pay anything. Which bring up some creative ideas for utilizing Spot, but yeah. Okay, thank you very much, everyone.